Imagine you're tasked with building a house. You could start from scratch, chopping down trees for wood, forging your own nails, designing every single structural element yourself. This gives you control, but it's time-consuming and error-prone. Now imagine instead that you start with a pre-built frame, a solid foundation. A detailed blueprint and foundation save you reinventing the wheel. This scaffolding provides essential structure without building everything for you. You can focus on the creative parts: interior design, room layout, choice of windows. In software, a framework is that scaffolding: foundation, walls, roof, data, logic, presentation. A software framework provides a standard way to build and deploy applications. It is a collection of pre-written code, libraries, and tools you can use and extend. Instead of worrying about low-level details like web requests or DB connections, the framework handles boilerplate, security, connections, repetitive tasks, letting you write less code. That means faster development, fewer bugs, and more maintainable software in the long run. In the vast Java ecosystem, the Spring framework stands out as a true giant. At its core, Spring is an open-source application framework for enterprise Java. Java enterprise development used to be cumbersome, heavy specs and lots of boilerplate. Developers dealt with mountains of XML and repetitive configuration. Spring emerged as a lightweight, flexible alternative to make developers more productive. It promoted POJO-based programming, plain old Java objects, easier to test and maintain. Its popularity grew because it solved real problems, removing tight coupling and modularizing code. Where monoliths were brittle, Spring encouraged loose coupling, components you can change independently. That modularity is a cornerstone of modern design and a reason Spring dominates Java backends. Spring is not one thing, it's a vast ecosystem of projects and modules for many needs. Think of Spring as a developer utility belt, tools you no longer have to craft yourself. It shifts focus from plumbing to delivering value to users. The Developer Plus Framework partnership enables complex, feature-rich apps at scale. Projects that would take months can start delivering features in days or weeks. That productivity is why Spring's legacy endures across industry. To understand Spring's power, learn two fundamentals: inversion of control and dependency injection. They work hand in hand to make components loosely coupled and testable. Inversion of control flips who is in charge. Your code no longer constructs and manages every object. Traditionally, code creates its dependencies with new and manages their lifecycle. With IOC, you declare what you need. The container creates and manages those objects. The Spring IOC container instantiates services and provides them when required. Dependency injection is the mechanism that implements IOC. The container injects dependencies into your classes. Think of your class as a chef who needs a whisk, a payment processor. The container is the kitchen assistant that hands it over. Your code stays clean, no new everywhere, and you can swap implementations easily. During testing, the container can inject a mock, letting you test components in isolation. Loose coupling and testability, the hallmarks of maintainable systems. Spring wires components together and lets you build complex systems from simple, testable pieces. Dependency injection makes unit testing straightforward and reliable. The framework handles the how, you focus on the what. IOC and DI are the foundations that make Spring powerful and maintainable. Spring's power extends beyond DI. Its ecosystem of modules addresses nearly any application need. Think of modules as expansion packs, add only what you need. Spring Boot is transformative, an opinionated, just-works experience that auto-configures apps. It scans your class path and auto-configures things like a web server for you. For web apps, Boot can configure a server such as Tomcat automatically. Spring MVC implements the Model View Controller pattern for web apps and REST APIs. Model, the data and business objects. View, the UI or API responses. Controller, routes requests to handler methods. Separation of concerns makes apps easier to develop, test, and maintain. Spring Data simplifies database access, SQL and NoSQL alike. Spring Security handles authentication, password hashing, and endpoint protection. Other modules support messaging, big data, and distributed systems. Pick what you need and keep your app lightweight and tailored. With these modules, Spring is a flexible toolkit that adapts from simple services to complex systems. As a computer science student, choosing what to learn can feel overwhelming. If you plan to work in Java, learning Spring is one of the best investments you can make. Spring is the dominant foundation of modern production Java. Startups and large enterprises alike rely on Spring and its ecosystem. Having Spring on your resume signals familiarity with production-grade applications. You'll learn DI, loose coupling, AOP, and other professional patterns. These lead to modular, testable, and maintainable code. Working with Spring helps you internalize professional software design skills. The Spring community is active, with thorough documentation and many learning resources. Tutorials, books, courses, and Quanda make learning approachable. Solutions are often a quick search away. Mastering Spring opens doors to many roles and companies. It's more than a resume line. It equips you with tools, patterns, and a modern mindset. With Spring Boot making it easy, there's never been a better time to dive in. Learning Spring makes you a more capable Java developer and opens career opportunities. It's your ticket to the modern Java revolution. Start exploring Spring today.